Hello everyone, welcome back to Let's Crack J in English, the channel of Unacademy. And I am Jeetendra Dixit. So let me just check my voice. Yeah, right. Okay, so I'll start with my introduction. Here is my profile. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. Alright, so one moment. Yeah. So before we begin, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform. And if you are preparing for IIT-JEE, then you can have two types of subscriptions on Unacademy. One is Plus subscription and another is an Iconic subscription. All right. So in Plus subscription, what you get, let me tell you. If you if you buy Plus subscription on an Academy, then you get unlimited access on the platform. That means you get access to daily live classes of all the educators who are teaching on an Academy. You get live tests and quizzes will also be accessible, all live tests and quizzes. So you know India's top educators are teaching on an Academy. You can follow, you can join their courses. You can choose your team as per your choice. You can choose your favorite. You can study from your favorite educator, right? So you get a complete freedom on the platform and unlimited access. Okay, once you get Plus subscription, and these are the subscription charges. You can subscribe for 1 month, 3 months, 6 months, 12 and 24 months. 1 month is 7,000 and 3 months it is 17,500. Similarly, 6 months it is 28,000 and 12 months it is 38,500, and similarly for 12, 24 months 56,000. So if you see average per month, then 12 and 24 months are the best packages which you should buy. Okay, recommended packages, and in that too you'll get 10% discount. Okay, in all the subscriptions whichever you choose. No, using the code Jeet1, so use this referral code and you'll get instant 10% discount, okay, while paying. So this was about the subscription of Plus, and now next is Iconic subscription. Iconic subscription, you get all the benefits of Plus, all the benefits of Plus. Wait a minute, just a moment. All right. So in Iconic subscription, you get all the benefits of Plus, and apart from that, you get a personal coach who will guide you throughout your preparation for IIT-JEE. Okay, and your test analysis will be done in a personalized manner. A study planner will be customized bi-weekly. Reviews will be given highlighting your progress. Okay, and all these benefits you'll get in Iconic subscription. Now these are the subscription charges. You can subscribe for you can subscribe for 12 months and 24 months. So 12 months it is 56,000, and for 24 months it is 86,000. You get 10% discount in these two. So it is final price for 1 and 2 year will be 50,400 and 77,400. Use this referral code JEET1 again and you'll get 10% discount here also. Okay, so I hope I'm clear. Now this is Unacademy's learning app which you can download from Play Store, and after downloading you just make your account and start learning. So before, if you don't have any subscription, then also you can access a lot of stuff for free. You can watch special classes. The special classes are live classes taken by all the educators of IIT Unacademy, and you can attend these special classes. Okay. So from first, if you are if you are downloading this app, then you'll have to use referral code of the educator. So you can use the same code which is JEET1, okay, from JEET1 to get access to all the free classes. Free classes means free live classes, which are called as special classes, and you can watch those classes without paying anything. Okay, you can use this code for that also. So this is Unacademy's learning app. Now you can see you can download this. Now we will continue straight lines. So this third session of straight lines. I was telling you the centers. So I've already told you the center, centroid, incenter, and circumcenter. Now, in today's session, I'll tell you about the orthocenter first of all. Now, see what is orthocenter. So, in a triangle, so altitudes, all three, you know altitude. If this is a triangle, in this triangle you can see you can drop three altitudes from vertices to altitude means perpendiculars from vertices to opposite side. Like this is one of the altitude. You can see this is one of the altitude. All right. From this vertex, say this is A, this vertex is say B, and this vertex is say C. All right. Now this is another altitude. Okay, and this is the third altitude. Okay, let me just draw it again. So this is another altitude. Okay, now it is looking like an altitude, and this is the third altitude. So you can see all three altitudes are passing through a point. That means they are concurrent at a point. Okay, so three altitudes of a triangle are always concurrent. Three altitudes of any triangle are always concurrent at a point. Okay, this point is called orthocenter, right? This point is called orthocenter of the triangle. All right, so in this you can see this point is orthocenter. Generally you denote it by capital H. You can take O also or any other letter. That is not a concern. Generally you see orthocenter is represented by H. Now this one more important point related to orthocenter, let me tell you. This orthocenter may be inside the triangle or on the triangle or outside the triangle. Okay, so if it is, see, this is an acute angle triangle. Okay, this is an acute angle triangle. Now if I make an obtuse, if I make a right angle triangle, then you can see so in right angle triangle, this is the altitude. Can you see? This is the orthocenter. Orthocenter is coincides with the right angle vertex. If you take this B and this is A and this is C, so right angle vertex is A and orthocenter will lie here, because you can see this BA is altitude. BA, this one side, two sides are basically two altitudes. BA is one of the altitude and the other altitude will coincide with CA, right? So these two altitudes are meeting at point A, and the another altitude which you draw from A upon BC, this of course will meet these two altitudes at A only. So these all three altitudes are meeting at point A. So right angled vertex is the altitude. Now let me draw the third diagram. Okay, when obtuse angle triangle, then how would it look like? Let me tell you that. So if it is obtuse angle triangle like this, okay, if it is obtuse angle triangle, then see how this altitude will be. If you extend this side, this AC, so this is A, this is C, and this is B, okay, then you drop a perpendicular from B upon AC. This is one of the altitude. Okay, this is one of the altitude. Okay, let me draw it again. Let me draw it separately here. because you won't be able to see this here. So I'm trying it again. Okay. So see, this is an obtuse angle triangle. Okay. In this obtuse angle triangle, you can see your altitude from vertex B, suppose this is A and this is C, all right? So from altitude from B will be this, right? This is, you can see this angle is 90 degree. If you extend this side, if you extend BA, then altitude from C will be outside the triangle again. And these two altitudes you can see are meeting here outside the point. So this is the orthocenter. And the third altitude, if you draw from A to BC and extend it further, okay, backside, this towards A, then this third altitude will also pass through this point. This is orthocenter. This was orthocenter, okay? This is orthocenter. This is orthocenter, all right? So now you can see orthocenter can be like orthocenter, orthocenter, orthocenter lies inside the triangle if triangle is acute angle, right? At right angled vertex if triangle is right angle triangle and outside the triangle if triangle is obtuse angle. Okay, so in this way you can figure out that this point altitude, this orthocenter may be inside, outside, or on the so most whenever they are asking this question to find the orthocenter of a triangle and sides are given or maybe vertices are given, then always check whether it's a right angle triangle or not. Because if it is a right angle triangle, if it is right angle triangle, then you can do the calculation very easily because you need to find the right angle vertex only. So maybe it is given, or maybe if equations of lines are given, then you can solve those lines and find this right angle vertex, and it will be easily done. So always check whether lines up or whether triangle is right angle triangle or not. Okay, so I hope it is clear. Now let me tell you the formula. If this formula is always valid, uh, although we are not going to apply the formula for right angled vertex, we'll solve the altitudes. We'll write the equation of altitudes and we'll solve them. So when we'll study straight lines, how to write the equation of a straight line, then we will be able to solve these questions of finding orthocenter. Okay, I'll tell you one more relation, but let me finish this. X2 y2 and cx3 y3. So say H is the orthocenter here, orthocenter. Now the formula for orthocenter, let H is H comma K. So orthocenter H, which is H comma K, of triangle ABC is, okay, so H is given by, say this angle is A, this angle is B, and this angle is C, okay. Then it is x1 tan A, this is the formula, plus x2 tan B, and plus x3 tan C, divided by, it is tan A in plus tan B plus tan C, okay. This is the formula for x coordinate, and for y coordinate, k is equal to, it is going to be x2 tan A, sorry, y1 tan A, I'm sorry, y1 tan A plus y2 tan B plus y3 tan C, okay, divided by same sigma tan A tan B plus tan A plus tan B plus tan C. Okay, so I hope you're getting this point now. All right. Okay. Now, let me tell you one more point. And the point is, this is an important point. I'm telling you a few relations. First of all, in equilateral triangle. In equilateral triangle, all centers coincide, okay? If this is equilateral triangle, A, B, C, this A is equal to B is equal to C, okay? Equilateral. So in equilateral triangle, all three altitudes coincide. This is one of the altitude. This is another altitude. And these altitudes are medians, these altitudes are angle bisectors and everything, okay? So these lines which I'm drawing are, you can call them median, you can call them altitude, you can call them angle bisector, you can call them perpendicular bisectors, okay? Anything, okay? So these are the points. Hello Jia, good evening, good evening. I've just started. I was just teaching Ortho Center. You do you know Ortho Center, Circumcenters, and uh, I have already taken two sessions. This is the third session. In this session, I am teaching Ortho Center. Okay, this is the formula for Ortho Center. You know what is Ortho Center? Today's class was shifted. Okay, today's class was at today it was at 8 p.m. but tomorrow it will be 3 p.m. Okay. Huh. So I was just teaching the formula. Actually, when we will do a straight line, after that we'll practice questions based on ortho center, circumcenter, and all the centers basically. Okay, so I was telling that in equilateral triangle, all centers coincide. Okay, all centers coincide in equilateral triangle. All centers, which not X centers. All centers means in center, ortho center, circumcenter, and centroid. All these centers coincide. Okay. Now one more point. Do you know Euler's line? In any triangle, this is very important. This point is very important, and it is going to be used a lot, almost in every exam. They make good questions based on this point. This is about Euler's line. Euler's line is line joining in any triangle. In any triangle, orthocenter. See, I am drawing this altitude because orthocenter lie on the altitude. तो थोड़ा सा ऊपर की तरफ, and now draw median. See, I have made this triangle in which one side is looking greater than the other, like this. Okay, इसको मैंने थोड़ा सा extended बनाया है, AC. Okay, if you make the triangle like this, then you can easily see this altitude is like this and median is like this. Okay, because midpoint will be towards this right side of altitude. So D is the midpoint, say E is this foot of altitude, and perpendicular bisector passes through the midpoint, right? Perpendicular bisector of BC. This is perpendicular bisector. So which point lies on perpendicular bisector, Gia? Do you know which point lies on perpendicular bisector? This is orthocenter. This is centroid. And circumcenter. Okay, circumcenter. Let's take circumcenters O. So this is circumcenter, yes, very good. Circumcenter lies on the perpendicular bisector. If you join these three, then this line is called Euler's line. And this centroid, you know that centroid divides median in the ratio of 2:1. And you can see these two triangles, triangle GAH and triangle GOD. GOD, this is D. These are similar triangles, right? Similar triangles. So if this ratio GA upon GD is 2:1, then same ratio is going to be GH upon GO also. That means, now this is the important point, that centroid divides orthocenter and circumcenter in the ratio of 2:1. Okay, this is an important point. We'll use this point later. Okay, so I hope it is clear now. All right, no problem. Okay, take care. Nowadays you guys are attending so many online sessions, so obviously okay, you can watch it later. Now I'm starting. Let's solve locus. Oh, wait a minute. One more point is remaining. X centers. Let me cover that also. X centers. So X centers. What is X center? I'll tell you. If you draw a triangle, see four circles can touch all three sides of a triangle. 4 circles. If you draw 3 lines which are forming a triangle, then how many circles can touch these 3 lines? How many circles can touch these 3 lines together? 4 circles. 1 is in circle and 3 are X circles. Okay, 3 are X circles. So let me show you the X circles first of all. I'm just extending these sides. Okay. Yes, obviously in circle will touch these 3 lines internally, and X circles touch one of the side of the triangle, and remaining 2 extended sides, A, B and C. This is the triangle. Okay, so if I draw the circles, then circles look like this. This is the first X circle. Let me draw it here. Opposite to A, which is touching side BC at some point, this point of contact, and 2 extended sides. Okay, so this is first X circle, whose center we are going to take C1 and radius R1. Such standard notation, radius R1. So radius of this circle, and obviously because it is touching AC and BC, so its center is going to be on the line on the angle bisector of angle A. On the angle bisector of angle A. This is angle bisector. So just understand the geometry of this circle, and then of course we can draw these 2 circles also. One is going to be here, like this, touching AC and 2 extended side. So one X circle is going to be like this. This will radius of the circle is called R2, and the third circle is going to be like this. Okay, so these are 3 X circles, and in circle we have already done, right? Now see the angle bisector of angle A. This is the angle bisector of angle A, and center of the circle C1 will lie on this. Why? Because if the circle touches these 2 lines AC and BC, then its distance of center from these 2 lines must be equal. And you know, when are these 2 distances equal? If distance of C1 Distance of C1 from AC and BC. Okay, distances are these two distances are equal. That means C1 lies on the angle bisector of angle A, and also C1 lies on the angle bisector of angle B, external angle, external angle. Okay, this angle bisector, this angle bisector. Okay, so two external angle bisectors. Why this angle bisector? Because this circle is touching BC as well as this, say this is BE. Okay, this point is E and this point is F. So it is touching BE and BC. So obviously it should be, whenever a circle touches, let me show you this. Whenever circle touches two lines, if a circle is going to touch these two lines, then its center will always lie on the angle bisector of these two lines. Why? Because these two distances will be equal, right? Radius, radius. Okay, so a point which is equidistant from two lines lies on the angle bisector of those two lines. So that is the point, because of which we can say there's these three angle bisectors, two external angle bisectors, external angles B and C, and one internal angle bisector A. They all will meet at this point C1, and this will be the center. Okay, this will be the center. So I'm just telling you the geometry of this, and yeah, and then you can draw altitudes. So these are the altitudes. So this is the altitude. This is R1, this is R1, and this is also R1. Okay, these are the altitudes. Circle is going to touch at this point. This altitude and AC1 are different lines. Okay, do not mix, do not take them together. Okay, so these are 3x circles. I'll tell you the radius. So radius R1, radius of this is R1, radius of this is R2, radius of this is R3. So I'll tell you the formula for, just like I have told you the formula for in circle. Now for x circle, x radii, R1 is delta upon S minus A. You know the notation. Delta is area of the triangle, and S is semi-perimeter, A plus B plus C by 2. And you know, side opposite to A is A, side opposite to B is B, and side length opposite to C is C. All right. So this is the formula for R1. The circle which is touching AC, X circle, radius of that is R2 is equal to delta upon S minus B, and R3 is equal to delta upon S minus C. Okay. Okay. And X circles obviously will always lie outside the circles. Will always, like in circle is always inside the circle. X circle is always outside the circles. Now another important point is that if if vertex A is x1 y1 and vertex B के coordinates x2 y2 and coordinates of vertex C are x3 y3, then x centers, let's say C1. Okay, then C1 x centers, x center of circle C1, which is, let's say, h comma k. Okay, h comma k, then h is going to be, it is very similar to the formula of in center. The only thing is that the formula of in center was a x1 plus b x2 plus c x3 divided by a plus b plus c. You just need to replace a by minus a. Okay, a by minus a for the centers of C1, b by minus b for the centers of C2, and c by minus c for the centers of C3. Okay, this is C2, this is C2, which is opposite to B, and this is C3, which is opposite to C. Okay, and k, y coordinate is minus a y1 plus b y2 plus c y3. So just remember the formula and directly use it. So these are the form. This is about the X circles. So now I have told you all the centers, which center lies inside the triangle, how do you construct these triangles, circles, okay, everything about these centers. So I hope now it would be clear. Let me give you a few questions. Now you try this one first of all. If cos theta 1 comma sin theta 1, cos theta 2 comma sin theta 2, and cos theta 3 comma sin theta 3 are the vertices of a triangle ABC. Take any triangle, then find centroid of the triangle, second, centroid of the triangle, second, in terms of theta 1, theta 2, theta 3, no problem. Centroid, you can find the centroid and circumcenter. And third one is orthocenter. So try this one, okay? Try this example. Have you got it? Just a moment, I'm going to discuss it now. All right. Now let me show you. First of all, centroid is very straightforward. Centroid is, say centroid is G, so it is cos theta 1 plus cos theta 2 plus cos theta 3 divided by 3. Second is sin theta 1 plus sin theta 2 plus sin theta 3 divided by 3. Okay, so there's no doubt about it. Now the second point is very important. The second point is about the circumcenter, sorry. So you know that all these points A, B and C are equidistant from circumcenter. Okay, so you can see these coordinates are cos theta 1 comma cos sin theta 1. Okay, so you know this is an observation where cos theta 1 and sin theta 1, although for now it is an observation, but once you have done circles then it will be very obvious point for you. The distance of A from origin is basically 1, because distance of cos theta common sin theta from origin is under root of cos square plus sin square. So under root of cos square plus sin square is nothing but 1. So distance of A means this vertex, and B and C from origin. Okay, origin, this is O, 0 comma 0, this is 0 comma 0, this distance and this distance, all three distances are 1. Okay, 1. That means origin is equidistant from these 3 points, 3 vertices. Okay, that means origin is nothing but the circumcenter, because only circumcenter is equidistant from all 3 vertices. So circumcenter is origin. Now the third point is orthocenter. So I wanted to let's say you can use that Euler's line. Okay, this is circumcenter, this is centroid, and this is orthocenter. This ratio is 2:1. But you can remember, I'm just mentioning this point here, whenever your circumcenter is 0 comma 0, your centroid is h comma k, then your orthocenter is going to be 3h comma 3k. Directly use this. Okay, see how if you want to calculate this, say this point is x comma y. All right, so circumcenter generally they give 0 0. Centroid you can find straightforward. Okay, x1 plus x2 plus x3. So it's very easy to find centroid. Then to find orthocenter you need to use this relation. Okay, so how do you use it? See, apply section formula. So you can write 2 into 0 plus 1 into x divided by 3 is equal to nothing but h. So you can see h is going to be, x is going to be 3h. Similarly, y is going to be 3k. Okay, so in this way you can find orthocenter applying section formula. So now here, you know, h is cos theta 1 plus cos theta 2 plus cos theta 3 by 3. So 3h will be cos theta 1 plus cos theta 2 plus cos theta 3. Yeah? So this coordinate, x coordinate of this is cos theta 1 plus cos theta 2 plus cos theta 3, which you can write sigma cos theta 1, comma sin theta 1 plus sin theta 2 plus sin theta 3. So these are the coordinates of orthocenter. All right, so this is a very important point. This is something which I was trying to mention here. Okay, so I hope you would remember this point. Okay, now let me tell you the formula of area of the triangle. After that we'll start locus from next session. So area of the triangle, area of the triangle whose all 3 vertices are given. See, there are many formulae for area of the triangle. You know this formula, you know, right? So delta, if area of triangle ABC is written as delta, then you know delta is equal to under root of s into s minus a into s minus b into s minus c. S is usual notation. S is a plus b plus c by this is the triangle. This is the triangle whose this vertex is a, this vertex is b, and this vertex is c, and side a, b, and c. Okay, so s is nothing but a plus b plus c by 2. This is Heron's formula. This is called Heron's formula, right? And then another formula is 1 by 2. If you say this angle is a, then 1 by 2 b c sine a. If you know 2 sides and including angle, you can apply this formula. Or you can write 1 by 2 a b sine c, right? If you use a and b, then angle is going to be c. Or you can use 1 by 2 ac sine b. All right. So if any two sides are Divya, you are saying that I'm weak in differentiation, then can I start integration? Actually, all the formulae of differentiation, uh, see, as such, differentiation is not required, but basics will be required and all formulae will be required. Either you need to remember all the formulae of differentiation. If you don't know that, then you'll have to memorize all the formulae of integration. It becomes easy for those who know the formula of differentiation. For them, it becomes easier to relate. Okay, because it is just opposite to that. If you are in class 10, then if you want to do integration, then see, differentiation is easier, very much easier than integration. So first you should finish differentiation. It won't take much time, because differentiation is not difficult for anyone. Maybe in class, maybe you are in class 10th, then for you it might be difficult, but integration will be more difficult. So you should do first differentiation and then you can jump to, then you should start integration. Div. Got the point? So I've done, but at inverse functions. So if you have, no, so just memorize the formula, na? What's the problem? Just memorize the formula of inverse functions of, because you'll get the inverse in integration also. Whenever you have like integration of 1 upon under root of 1 upon 1 plus x square dx. Then this is the integration. This is tan inverse of x. And if you differentiate tan inverse x, you will get 1 upon 1 plus x square. So they are related, right? It's the inverse process, integration, reverse process. So if you know the formula of tan inverse differentiation of tan inverse, just memorize the formula. And you know the basics of differentiation, then it is like a function. It is like sine x, it is like tan x. If you know the differentiation of log x, if you know the differentiation of sine x, then you should know the differentiation of tan inverse x also. Just treat this as a function, as any other function. Got it, no? But I would say that you should do differentiation first, okay? Formula, if you are missing some formula, that is not a concern. You should know the rule, how to differentiate. You should know UV rule, because in integration, when you are substituting, then you need to differentiate for some functions. Whenever you're putting some function is equal to t, then you'll have to differentiate it. All right, it's all right, no problem. I'm here just to help you guys. Okay, so we were doing area of the triangle. I have told you two formulas so far. The next one we are going to do in terms of the coordinates. So if coordinates of the vertices are given x1, y1, x2, y2, and x3, y3, then area of the triangle is area of triangle ABC can be written as 1 by 2 of, you can write an area, so you need to put mod also, x1 into y2 minus y3. See this, these are in order 1, 2, 3. Then it is going to be x2 y3 minus y1. You can see the cyclic order 2, 3, 1. Then it is going to be x3 y1 minus y2. Okay, so it is easy to memorize. If you see the pattern x1 y2 y3, so 1 2 3, in this way you can add 1 2 3 2 3 1 3 1 2. Okay, another way of writing this formula is 1 by 2. You can write y1 outside and then x2 minus x3. In this way also you can write it y1 then x2 minus x3. So 1 2 3 again, these numbers will be in the same order. Y1 is outside now and x2 minus x3 is inside. Then it can be y2, then it will be, second term will be y2 x3 minus x1, and the third term will be y1 x2 minus x3. Okay, so in this form also you can write the formula. Okay, in this form also you can write the formula. All right. So this is area of the triangle. Now let's do some questions based on this. Now let's apply this. Area of the triangle whose vertices are first one is t comma t plus 2 comma t plus 3 comma t plus 2 comma t plus 2. All right. So vertices are given in terms of some parameter t. It's all right. Find the answer. If vertices of a triangle okay, so area is 1 by 2 t into okay, so x1 into y2 minus y3, so it is t minus 2, all right, plus x2, that is t plus 3 into t plus 2 minus t plus 2, so that is t minus 2, okay, and the next is plus t plus 2 into x3 into y2 minus y1, so t plus 2 minus t, all right. Yeah, that is the answer. Just simplify it and it's done. This will get cancelled and this will get cancelled and get 0 in the middle term, and here it is 2. So now see what is the answer, whether it is in terms of t or a constant. So it is t, first term is minus 2t, second term is 0, and third term is going to be plus 2t plus 4. This 2t and 2t will get cancelled. It is going to be 4 by 2, 4 by 2 is 2. Alright. Now that is the answer. Now one more question, okay, one last question, and then we'll start locus from. So if area of the triangle formed by, if area of the triangle ABC, where A is x comma y, B is 1 comma 2, and C is 2 comma 1. Area of triangle ABC is given 6 square units. Then find x plus y. That is the question. Try this one. All right, so let's apply the formula. Area of the triangle, we need to put mod also. In the previous question, we had put mod, but mod of 2 is 2, all right? So that's why answer finally you can remove mod once you get the number. It's a positive output. 2 was positive. So now in this case, area is 1 by 2 mod of, okay? So now it is x times of, you can see x1, 2 minus 1 plus x2, which is 1 into y x2, y3 minus y1. So there is 1 minus y. All right, you can see that. Yeah, 1 minute. Yeah, okay. Plus x3, which is 2 times of y minus what is that, y minus 2. All right, yeah, this is given 6, this is given 6. Okay, simplify it. So it is going to be x only minus y and plus 2y minus 4. This is equal to 12, and this is x plus y minus 4. X plus y minus 4 is equal to plus minus of 12. So it is going to be x plus y is equal to 16. Okay, if you take plus sign, or x plus y is equal to minus 8. Yeah, x plus y is equal to minus 8. Let me check. Wait a minute, let me check the calculation. Oh, we missed 1. So this 1 into 1 was 1. So it was x plus 1 minus y. So plus 1 will also be there. And if 1 is there, then it is going to be 15 finally. Okay. So if we take plus sign, it is going to be 15. This is the calculation error. This is 15. Okay. And if you take minus 3 and minus 12 plus 3 is 9. So this number is going to be 9. So these are the answers. So values of x plus y will be either 15 or minus 9. Okay. So do not forget to put mod when you're writing the area. Okay. Using this formula. Because using this formula, you might get a positive value or you might get a negative value if all the vertices are not given in terms of numerical values. Okay. If some parameter is involved, so you'll get the expression of that parameter, maybe linear, maybe quadratic, depends how in which form that coordinate is given in terms of the parameter. So you will get the expression for area. So you need to put the mod on that expression, because that expression can be positive or negative. Okay, like in this case, it was an expression of x and y. Area was an expression of x and y, and it was equal to 6. So we need to put mod on that expression, and then when we remove mod, then it will be plus minus of the number which is written on the right hand side. Okay, so we might get 2 values of the variable or 2 values of the expression. Okay, so that is what is this is an important point, but this was related to this area. Now we will start locus. Okay, so we are done with this basics of coordinate geometry, all the centers and all. Now we will find centers. We'll do questions based on these centers. Once we'll study straight lines, the form of straight lines we are going to. Okay, after that we'll study this. All right, thank you very much.